Maybe you know my videos about Stable Diffusion with Automatic 11.11 Web UI. Comfy is another great UI for image generation which gains increasing popularity. The reason is not only being very configurable with great workflows and using less memory than other UIs, but also the support of different diffusion models. It was the first one to have support for Stable Diffusion 3, and yes, you can use the fantastic Flux with Comfy. More on that later. In the past I made videos about the installation of ComfyUI, mainly helping users of AMD GPUs, but have not dug that much into the depth of Comfy's endless possibilities and brilliant functions, which is going to change right now. Beginning with this tutorial, I start a series of Comfy how-tos and I invite you to learn together with me all those great things this tool can provide, including best workflows not only for the basics like upscale in Paint, phase swap and many more, but also covering integration into other tools and maybe even automation, all in relation to current models, including for example Flux.1 wherever possible. If you want to join me on this track, press the subscribe button and ring the bell. We start with the installation. As usual, you can find all links in the description. In order to install Comfy, go to this GitHub page and then, that is Comfy Anonymous. Here you can find a link to ComfyUI and to some example workflows. Let's go to ComfyUI. Then you find a link to the section for installing Comfy. There are several options to install Comfy. The most easy way is to install the portable standalone build for Windows. Just click the link to download the 7-zip archive. 7-zip compresses archives very similar to zip. As it is quite popular, you might already have a tool for uncompressing a 7-zip file on your PC. If this is not the case, then simply click on this link, go to the 7-zip homepage. Most probably this is the version you want to download. The installation is not very difficult. I will install Comfy on my C drive in my KI directory. Most probably you will choose a different name, maybe AI for example. If you have installed 7-zip, then you can simply double-click the downloaded archive and simply drag and drop the archive into the target directory. The archive is not required anymore. Within the Comfy Windows Portable directory, you find two batch files. There is still one thing to do, and that is updating Comfy to the latest version. Enter the update directory and now careful, do not start this BAT file. It will update the Python dependencies and it's only required if you have some trouble with the embedded Python. Instead we use the update Comfy BAT file. Just double click and the changes are applied. Now we have the latest version. And last but not least, the latest version is required for the Flux.1 model. If you're using an NVIDIA GPU, then you're lucky. You simply have to double click and Comfy will start. If you have a different GPU, then you can still use the Run GPU BAT in order to start Comfy, but that will be very, very slow. If you have an AMD GPU, then you can simply watch my video about Luda and install the best option to run Comfy with an AMD GPU. See this link. Alternatively, you can install Comfy on Linux and there is another link. There is another option and that is running Comfy with DirectML. It's not the best option because as of today you cannot run the Flux models with DirectML. Anyhow, in order to give you this option, we will quickly install DirectML. NVIDIA users, well, can just jump to the next chapter. Simply open a command window, enter the right directory, into the Comfy portable directory and make a copy of the run CPU batch file, but rename it to DirectML. Open this file in your editor and we enter a different line for calling starting Comfy. The difference is, instead of the parameter for the CPU, we use the DirectML parameter. Low VRAM is usually a good idea. Windows standalone build, well, that stays as it is. And there was a hint to use split cross attention. This seems to be a good choice too. We delete the first line and save. Unless this won't work, because till now we don't have Torch DirectML installed. Don't be confused by the next command. This simply installs the command get pip. So most probably now you won't be able to move this directory anywhere in order to run it at a different place, but this shouldn't be a problem. Now this line is for installing Torch DirectML. By the way, don't do this on an NVIDIA system. Don't get confused by this error. It will work anyhow. It simply has downgraded Torch to the DirectML version. And I think that's the reason why you cannot run Flux.1 with the DirectML command. Torch Audio is missing, but we won't use that anyhow. In order to be on the safer side, we just make sure to have the right version of NumPy installed in our embedded Python directory. As you can see, it's already installed, but I just wanted to make sure that there is no issue with the compatibility of NumPy. Now we're ready to start Comfy. You have the option to double-click the right BAT file or start the BAT file from this command window. I usually choose this command window because by doing it that way I'm very sure to see any problems and errors. Again, choose Run CPU only in case you have no other option, because it's very slow. As I have an AMD GPU, I start Run DirectML. By using the CPU BAT or the NVIDIA version, you shouldn't experience such errors. It's not a problem because we do not use Torch Audio. So even with an AMD GPU, it will work. Well, now in the background you have the ComfyUI. You can increase and decrease the size with the mouse wheel. Just make sure to have the mouse pointer not inside of one of the nodes. You can drag and drop all nodes. And you see these nodes are connected. Each connection transfers some data. Don't be confused, you don't have to know all these nodes today. You have the option to learn more about these nodes in my following tutorials, or you can simply use these workflows, so this is a workflow, in order to generate images. It's very easy to find and load new workflows. You'll see this in a few moments. Nevertheless, this won't work because we have no checkpoint so far. So when we use these command buttons, then here is a button Q prompt. That's the most important button because it will start the generation of images. With load and save you can load and save workflows, refresh, well, I think that's okay. With clear you can clear the whole workspace, and load default simply creates a very basic workflow. Let's use this option. Okay, this is very basic. And in the load checkpoint node, you see there is already a v1.5 pruned checkpoint. In fact, it's not in the Comfy directory so far. So if we press the Q button, then there is an error because we do not have any checkpoints. Let's change this. I don't want to use the standard Stable Diffusion 1.5 checkpoint. Usually I use Epic Realism for this. You simply can press this button in order to download this customized model. Once the model is downloaded, you can simply go within your Comfy Windows Portable directory to Comfy, Models, and in checkpoints, you would place the Epic Realism model, for example, or whatever checkpoint you want to use. I won't do this because there is an even better option. In case you use Automatic 11.11, within the ComfyUI directory, there is this extra model path YAML example. Just remove the example string so that it's called extra model path YAML. Let's edit this file. If you already have an Automatic 11.11 installation, then you should put here the base path. In case of my PC, it's in CKI, Stable Diffusion, Web UI, DirectML. So let's copy this path. And I think we have to place the slash with the backslash. So we do it that way. And usually I do not put the drive letter there. Okay, this should work. I think a refresh is not good enough and we have to restart the Comfy server part. So let's start again, and then the model should be found. Let's reload the UI. And yes, these are the models from my Automatic 11.11 installation. Let's choose Epic Realism. And now, as before, we simply press the Q prompt button. And yes, it works. We have generated our first image. I know DirectML is quite slow, but when we change to the Flux model, then I will use Sluder and this is faster. Just to give you an overview what we have done so far. We have one node for loading the checkpoint. Here you can simply select your checkpoints. As you might have guessed, we have a clip text encode that is for the positive prompt, and there is a second clip text encode node that's for the negative prompt. The dimension of the image is configured in the empty latent image. Here you can enter the width, the height, and even the batch size. If you're working with complex checkpoints, I would suggest to leave the batch size at 1, and there is a different option to generate several images in one go. Because in the command panel, in the extra options, here you can simply increase the batch count. And by doing it that way, there seem to be less problems with RAM and VRAM, just in case you want to do this. The K-sampler includes lots of parameters you might know from Automatic 11.11. The seed is a random number influencing the generated image. The image will look different for each different seed. And you can control how to continue with the seed. Have a randomized seed after generation, increase, decrease, or simply have it fixed. Fixed might be a good option if you just want to modify an image by using different prompts. The steps, well, here it's 20. Usually I choose even 30 for epic realism. The CFG is a bit high for this model. We can just choose, say, 5. Sampler, well, Euler is quite often a safe choice. For this special model we can choose DPM++2M STE and the scheduler Keras. So all that is very similar to what you might know from Automatic 11.11. As we're generating a new image with Txt2Img, you can safely leave the noise at 1.0. So let's run again. And yes, as expected, it looks quite different. By the way, the weighing code is fed both with the result from the K sampler. To the right of the nodes you always have the output, to the left there is the input. And the VAE is baked into this epic realism model, so we do not have an extra model for this. And after the VAE decode, we have the resulting image. You can find these generated images in Comfy output. These images do not only include the, well, picture information, they also include the information about the workflow. So if we remove this workflow by just pressing the clear button, and now just taking this image with drag and drop, we have exactly this workflow including the seed we have used before. This can be very handy if you want to just generate another variant of a certain image. And of course, these workflows are transferred very easily with the PNG images. So if you find a certain workflow for Comfy in the web, you can simply drag and drop it here and then you will have this workflow. That's what we will do for Flux 2. Now that we have successfully tested Comfy, let's continue with the fun part, with Flux.1. 3 different models have been announced. A so-called Flux.1 SCHNELL version, SCHNELL is fast in English, a Flux.dev version and a Flux Pro version. You can use Flux.1 SCHNELL even for commercial projects. The Flux.1 dev is for, well, for private usage and research, and the Flux.1 Pro version, well, that's the paid version of the Flux model. Nevertheless, well, I'm no lawyer, but as I have read, even the outputs, so the images you have generated with the Flux.1 dev, well, it seems that you can even use these images for commercial purpose. But as I said, I'm no lawyer and that's just what I have read. Regarding the performance, Black Forest Labs states that the SCHNELL version, which is a 4-step version, is on par with Midjourney 6.0. And that's definitely not bad. And remember, it's a free open source model under the Apache license, which you can download freely and generate images, well, for free. Dev and Pro are indeed a bit better, but the difference is not that high, and for most purposes the SCHNELL model is good enough. Nevertheless, I will show you how to run both the SCHNELL model as well as the dev model. The good thing is, in the GitHub Comfy Anonymous page there are even examples for Flux, and here's written exactly what we have to do. No worries, it's not that complicated and you will see how to do in a few seconds. If you have used checkpoints with Comfy or Automatic 11.11 in the past, then it might be a bit, well, strange for you that the models are separated in several parts. But by doing it that way, each file is a bit smaller, and in fact it's that you are even more flexible by using these different parts. If you want to do it the traditional way, so having just one file for each model, so one for the dev model and one for the SCHNELL model, then it could work the following way. At the bottom of this web page, you find the description how and where to download these, well, one file checkpoints, and here are the workflows for these checkpoints. This is for the dev version and this is for the SCHNELL version. Nevertheless, this comes with a price, because for both models we have an FP16 and an FP8 version, and the FP16 version has a higher quality. These one file versions are FP8 versions only. Don't get me wrong, even the FP8 versions consume lots of VRAM and RAM, but by using the proposed method and downloading the FP16 and FP8 versions, you have more flexibility, and I will show you the benefit of this in, well, a few moments. So first let's download all required files, both for the SCHNELL model as well as for the dev model. First we use clip files. These clip files are provided by Comfy Anonymous, and I suggest downloading all three of them. Yes, I know they're big, but the other files, well, they're even bigger. So just press these buttons and download all of these files. As I said, these are the clip files for the text encoders. Then, next step, we need an VAE file for the Flux models. So we go to the Black Forest Lab section on Hugging Face, and in this file there is, well, it's a VAE file, but it's not visible because it's too big. Don't get confused, use this link and download it, the VAE file. Once this is done, what we require now are the UNet model files. The UNet model file can be found here. In fact, you have to register in order to access this file. But no worries, you can simply download the SCHNELL model if you don't want to register. It's free even for commercial purpose, and it's this file, which is 23.8 GB. Press this button in order to download. As already mentioned, these files are very big, and the FP16 versions, well, they are that large that it might be difficult for your GPU to run these files. So on Hugging Face, using this link, you can find from the user KaiJ the FP8 versions of these UNet files. Simply click here in order to download both. So if everything is downloaded, we quickly move the files to the right directories. First, let's select the model files, cut and paste into models, UNet. Then the WAV file goes into the WAV directory. And finally the clip files well into the clip directory. I think that wasn't too hard, right? Okay, that's it. For sure you remember that we can simply drag and drop images being generated with a certain workflow in order to, well, have this workflow within Comfy, right? So we have these images here in the examples, and now we simply drag and drop this image, which is for Flux Dev, into the ComfyUI. Don't be confused, it's not that complicated, and today we'll will only generate some images and not discuss the function of each node. Let's see if we have put the models into the right places. So, okay, I cannot select anything. I guess we have to refresh. And now automatically the right, well, in this case, the FP8 version of the Flux unit model is found. So here, by just clicking, you can select all these versions. Same is true for the clip. And yes, we already have the AESFT WAV file. We could start the generation right now, but this model will consume lots of memory and the generation will be very slow. So I'll show you a better option how to start. In the examples there is a second image, and that's for the SCHNELL model. Just let's drag and drop. The workflow is a bit simpler, and by tuning some of the parameters it will consume less memory and will be even faster. So if you want to generate an image with Flux.1 the very first time and do not know about the performance of your GPU, please do it the following way. Choose as the unit model the Flux.1 SCHNELL FP8 safe tensors. That's smaller and faster. As weight type, choose the FP8 E4 version. It's faster and consumes less memory. And for the clip name 1, there we choose the FP8 version. And additionally, I encourage you to, well, reduce the size of the image in the very beginning. Let's choose 512 by 512. Now it's optimized as good as we can. Let's start the generation. What takes quite a lot of time is loading the model into the RAM or into the VRAM. Once this is done, the following runs of the workflow are much faster. So please be patient, even if it takes some time, it's only for the very first run that it takes that long. So on my machine it was around 50 seconds for the very first run. The second run will be faster. So 20 seconds on my machine with Luda is quite normal for this resolution. NVIDIA GPUs are much faster. Well, so Comfy even works with Flux.1 now. Let's have a look how I have generated the thumbnails. There's no magic in the prompt itself, it's simply a sentence describing the scene. Photo in perfect light of a beautiful blonde woman in a silver armor looking into the camera, holding with both hands an ancient wooden medium-sized sign with the golden edged words including Flux.1, standing in the front of a lake with a dragon flying and screaming in the upper right background. Before we have a look at the result, I set the random noise control after generate to fixed, because I want to show you the influence of the different models and qualities and how I normally do when creating and choosing images. By the way, there is nothing wrong to set control after image, for example, to increment, because by doing it that way, after generating a very good image, you simply can go back one step in the noise seed and you can just generate with the same seed and different parameters. That's not bad, isn't it? And also I like this image quality very much. There is one thing I like even more, and this is the precise interpretation of the prompt. We have the blonde woman in the silver armor. The sign is exactly as we have described it. There are all fingers and nothing is deformed. And the dragon is in the upper right, exactly as we have described. Anyhow, if you have generated an image with a composition you like very much, but where the result is not exactly as you've expected, I will give you some hints and tricks in a few moments. But first let's generate with the FP16 version of Flux.1. So we use SCHNELL FP16, that is the one without the number, and let's weight D-type as default. I think that's the highest value, and for the clip we choose the FP16 version. By the way, very first hint, if you just want to check if a prompt works, choose half of the width and half of the height and generate with the FP8 versions. That should be very fast and you get a feeling if your prompt works. If you are satisfied with the prompt, then you can set the target resolution and generate a batch of several images with that prompt. Then you search for an image you like, drag and drop it into Comfy and generate it with the same seed and, for example, the SCHNELL FP16 version or even the development version with the highest weight type and the highest clip, FP16 of course. Can you notice the difference? The face seems to be a bit more detailed and the dragon is a bit more, well, terrifying. Additionally, we have some more detail in the sign. But you have a chance to compare all 4 images as soon as we've generated the, well, 2 images with the dev version of Flux.1. 2 more hints. You can freely combine the models with the different weight types and the clip models. All combinations have influence on the performance and on the result. And regarding the generation parameters, don't take them as being fixed. For example, for the SCHNELL model, you can easily increase the steps to 5, 6, even 8 is possible. And similar for the dev model, which seems to be designed for 20 steps, well, you can even increase it to 25 or 30 steps. Currently, the community is not sure about the amount of difference, but there is a difference in image generation when just increasing the step size. And imagine the image is not perfect, say for some reason there are some fingers not as they should, then simply use the same seed and do the generation again with, for example, steps 6 or 8. If you're lucky, then the fingers will be fixed. And similar to Automatic 1111, you can simply choose different samplers. You do not only have to use Euler. For example, from what I have read, the... where is it? DDIM sampler seems to work quite good with Flux.1 and the UniPC sampler too. Just try some samplers and check the results. Before we continue with the dev results of this image, let's have a look at the performance. With best parameters for the SCHNELL model, it took 736 seconds. But remember, I have an AMD 6800 with 16 GB VRAM and the RAM of my PC is 32 GB. And if you have a look at the time for each step, then you can see that well, loading the model seems to consume lots of time. So because of that, when continuing the generation, there would be no loading time and the generation in whole would be faster. Using the lower quality settings, which result in a higher performance, and using the same resolution for the image, it's still 133 seconds. But again, most of that is the loading time of the model, so generation is around 1 minute. And next generation of an image would be probably just a bit over 1 minute and for sure not 133 seconds. Well, but that's just for my machine. For example, on NVIDIA machines, it's much faster. As the generation on my machine is very slow, let's just have a look at the results by using the Flux.1 dev models. So let's compare the results of the different Flux.1 models. This is the FP8 SCHNELL model with lowest settings. I like this image very much and I'm glad that there are no defects, because in Flux we do not have a negative prompt. Means in case of defects you have to change the positive prompt or the other parameters. And here we have the FP16 SCHNELL model with highest parameters. It's a slight improvement, we have a bit more details, but to be honest, I'm not sure which one I like more. Wow, what a difference! This is the result of the FP8 dev model and it definitely looks like a photograph. I like the face and the sign, that's a great improvement. Nevertheless, I think the fingers are correct, but maybe look a bit strange, and is the dragon looking to the side, so that's a bit strange. Okay, and that's the FP16 dev model, and it looks like a correction of the FP8 dev model. The hand looks better and the dragon has a neck and a head. Nevertheless, I wasn't too happy with this bag, and so I thought about generating again. My first try was to change the sampler from Euler to DDIM, but in contrast to what I have read before, there was absolutely no difference. It was the same picture. So my next try was increasing the steps from 20 to 30, and see, there is a difference, and that's great. We have a lot more detail, the sign looks much better, we even have a ring at the finger, and the dragon, well, finally it looks much more correct. So I thought, why not giving it a try and increase the steps to 50. We have a slight change, we have some details, the hair, the wings have much more detail, and the sign has some improvements. Nevertheless, you really have to think if it's worth spending nearly double the time for generating the picture, or if 30 or even 20 steps are good enough. Surely we cannot judge the Flux.1 models by looking at just one image. If I did, well, then for the dev model you should spend the time using the original FP16 one. Regarding SCHNELL, the difference is not that big. You might get along by using the high performance FP8 model. Anyhow, I keep my fingers crossed that we see custom Flux.1 models and especially performance optimized models. If you enjoyed the video, please leave a like and don't forget to write in the comments which comfy topics you want me to cover next, or which topics at all.